Hello. So today we will be presenting on the topic a solar power trail for Toronto International Airport Limited. The group presenting today is group number 5 and the members are Marisa, Josh, Sona, Mohammed and Manjima. So the topic we chose was to procure a solar power trial for the Toronto International Airport. So now we will be covering on the objective of this project. So this was actually a project that aimed to build a solar power facility next to the Toronto International Airport, which aims to produce clean and renewable electricity. So the main aim of this project was to reduce carbon footprint, making it completely self-sufficient in terms of energy needs. Moreover, to strive to be more environment friendly and sustainable, and it mostly focuses for the future. Now, this project consists of about 46,000 solar panels, which was dispersed over 45 acres of land, and this was situated close to the airport's cargo complex. Next is project organizational overview. So the organization that manages this TIAL is Toronto International Airport, and um, the business places a high priority on sustainability and advancing environment-friendly procedures in the aviation sector. And with the help of German Development Bank, that is KfW, a solar power plant that can produce about 50,000 to 60,000 units of electricity per day was constructed. And this organizational structures involved team that includes project managers, project coordinators, project quality, project controls, technical experts, procurement managers, etc. And they are all experienced in design, engineering, procurement, constructing, and commissioning of the solar power plants. And the TL Solar Project organization structure is basically set up to guarantee efficient project management. So this is all about the organizational overview of the project. Thank you.
So, greetings for the day. My name is Josh, and now I'm going to talk about the estimated supplier lead time. So, the estimated lead time is included of a total of 49 days, and this has the first one, which is the issue RPF. The request for proposal for the suppliers will be the first step, which will be taken on the 1st of November, and we have 25 days time to have the proposal return deadline, and then we'll be choosing the final supplier choices accordingly by the next 15 days. And then the negotiation time period given for this project is roughly around 9 days, and finally by the 49th day the contract award will be provided. With this time with this thing, we are trying to find out the product cells with the lead times as well, and this include the photovoltaic cells, which has a lead time of 4 to 6 weeks, the solar panels, which has again another 4 to 6 weeks time lead time, and then the inverter, which has 3 to 4 weeks time, and the frames, which has 3 to 4 weeks again, and finally the black sheet materials, which is used for the solar panels, which takes another 3 to 4 weeks time. So these are the whole product lead time requirement and the supplier requirement for this project. Thank you. So let's now talk about the technical and functional requirements. So the technical requirements and the functional requirements. The first one is the technical specification. The solar panel must be high efficient and long lasting enough to survive extreme weather conditions. Being in Canada, it has various high hot temperatures and also harsh cold climates as well. So it is very important to have those specifications. Next, we have the inverter. The inverter must convert the direct current power provided by the solar panels to alternate current, which is basically converting the DC power current to the AC power current. And then comes the transformer. The transformer must step up the voltage of the inverters alternate current electricity to meet the grid's voltage. This helps to manage the voltage capacity without delaying it or overheating it. Then comes the battery backup. It is very important to have a battery backup system which must retain the surplus power generating during a sunny day and provide the electricity at night or an overcast cloudy day. Then the electrical wiring and switchgear. The electrical wiring and switchgear must be able to handle the high voltage and current levels. This helps in association with the solar panels power system. Thank you. Now let's talk about the quality requirements. First one is the energy production. The solar power system must create enough electricity to fulfill the airport's energy requirements. It has high top rated requirements for the electricity, for the airway systems and everything. So the quality management for that is very necessary. Then comes the energy management. An energy management system is required to guarantee that the electricity is used effectively and productively. Then the grid connectivity. The quality requirement of the grid is something which is helping the solar power system, which must be linked to the grid in order to feed the surplus electricity back into the grid and draw power during the periods of low generation. Then comes the safety and security rules. The safety and security rules must be followed by the solar power system to guarantee that there is no problem in functioning and does not endanger the airport or the surrounding environments. Then comes the maintenance and services. It is one of the only airports which has a solar power system. So when the solar power system have a maintenance issue, it must be simple in maintaining and there should be a clear service plan in place to solve any issues that might arise. Then comes the Toronto Airport's whole quality confirmations. Basically, it helps in functioning of the whole airport system effectively without having any delay or problems in between due to this solar power system. And this helps the Toronto International Airport to have a solar project that will be able to have a generation of clean energy and lower the airport's carbon footprints by achieving these technical and functional goals. Now let's talk about the resource requirements. The logistics and the on-site assembly of the equipments and the supplies are among the resource requirements for the Toronto International Airport Solar project. The following are the logistics and the on-site assembly requirements. The first one, which is the basic part of the whole system, is the solar panel. The solar panels will be brought to the airport site by trucks and needed to be handled carefully to minimize the damage during the transportation. The panels must be assembled on site by mounting them on a pre-built frame that will keep them designed to keep them in place. Then comes the inverters, the transformers and the switch gears. The inverters, transformers and the switch gears must be delivered to the job site in big containers that requires heavy lifting equipments to unload. These components are very important and they should be assembled on site by mounting them on a pre-built platform and connecting them with electrical lines. Then the battery backup system. The battery backup system carried to the site also should be carried in big containers that need heavy lifting equipments to unload. The battery system will be assembled on site and installed on a prefabricated racks and connecting them with electrical wires. The electrical cabling is the next one. The electrical cabling used to link all the solar panels, the inverters, the transformers, the whole switch gears and battery system has to be handled with care during the shipping. The electrical wiring is assembled on site by routing the wire system via conducting and connecting them with the necessary components. So these are few of the major parts which is required for the research requirement. Thank you.
Hi, I'm Anjima Manohar and the first one is payment system for Toronto International Airport. The objective is to establish a payment system that incentivizes the contractor to perform optimally and deliver the project on time while ensuring quality and safety standards are met. Performance-based payments are established here, and the contractor will receive payments based on milestones achieved and performance metrics such as quality of work, safety, and completion of time. Milestones and payments. The first milestone is procurement of 46,000 solar panels and related equipment payment, 10% of the total contract amount. And the second one is completion of the solar power plant's foundation and installation of solar panels payment. It's 30% of the total contract amount. The third one is connection of solar power plant to the grid and commissioning payment. It's 40% of the total contract amount. And the fourth one is successful completion of trial run and handover to TL payment. It's 20% of the total contract amount. So a withhold amount of 10% of the contract value will be withheld until the completion of the trial run and handover to TL. The amount will be released after the contractor has demonstrated satisfactory performance and the project is complete. Payment terms. All payments will be made within 30 days of completion of each milestone. Payment terms will be outlined in the contract agreement. The payment system proposed for TL Solar project is designed to incentivize the contractor to perform optimally, deliver the project on time, and ensure quality and safety standards are met. The performance-based payment system and withhold amount will motivate the contractor to complete the project successfully, leading to the delivery of sustainable and environmentally friendly airport. Seller qualification. To deliver the desired product and services for TL, the required qualifications are: the seller must have experience in delivering large-scale solar power projects, preferably within a minimum of 3 similar projects executed in the past. The seller should have technical expertise in solar power system, including installation, design, commissioning, and the seller should have financial stability to complete the project on time and within budget. And seller must comply with environmental regulations and have a track of record adhering to environmental and sustainable standards, and he should have a quality management system in place to ensure that the project meets or exceeds the required quality standards. The seller must have a strong safety culture and a comprehensive safety program in place to ensure that the project is executed safely and without any accidents, and also should have a local presence in Canada, preferably in Toronto area. And the seller must have access to high quality solar panels, inverters, and other components required for the project. The seller should have a proven track record of delivering projects on time, within budget, with high customer satisfaction level. And the last one is the seller should provide a warranty for the solar power plant and ongoing support and maintenance service to ensure its optimal performance over its lifetime.
Thank you, Josh. So here I'm going to discuss about the seller response procedures. First is acknowledging the request. As a seller, the first step is to acknowledge that the request for a solar powered trail for the airport, and this can be done through an email or a phone call. So the alternate or a late response could be that the seller is unable to acknowledge the request immediately. They should notify the buyer of the delay and provide a new expected timeline for the response. The next step could be gathering information, which is to gather all the necessary information about the requirements of the buyer, which may include the size of the trail, the location, the capacity, and other specifications. The next is providing a quote. Once the information is gathered, the seller could provide an expected timeline that they should and negotiate the terms. So, in this, we should also include the cost of the solar powered trail for the installation, maintenance, and other related costs. Now, in the timeline of 2 to 4 weeks, we could negotiate and finalize the deal. After the quote is provided, the buyer and seller may negotiate the terms of the deal. Once the terms are agreed upon, a contract can be signed and the deal can be finalized. The next is, which is one of the most important steps, is procurement and installation. The solar powered trail is then procured and installed by the seller. And it has an alternative response is that if there are any delays in the procurement or installation process, the seller should notify the buyer of the delay and provide a new expected timeline for completing this process. So, this was mainly about the timeline. Overall, the timeline for procuring a solar power trail may range to 12 to 20 weeks, depending on the specific requirements and circumstances of the project, as well as any delays that may occur along the line. So, next, I would like to discuss about the various kinds of contracts that we're going to include in this. So the first one is the contract for engineering purpose and building, which is the EPC. This form of contract is used when a single provider is in charge of the design, purchase, and building of the solar power plant. The EPC contractor is accountable for completing the job on schedule, within the price, and in accordance with the technical specifications. The second one is the equipment supply contract. This sort of contract is used to purchase a particular solar power plant equipment such as the solar cells, inverters or transformers and the battery backup systems. This equipment supplier is accountable for providing the equipment on schedule and in accordance with the technical specifications. The third one is the contract for operations and repair. This form of contract is used to provide continuous operations and repair services to the solar power facility, which the plant's performance is monitored by the OM provider, which also provides routine maintenance, responds to equipment malfunctions, and replaces the faulty components as required. The power purchase agreement, which most of us has heard, is the PPA. This form of contract is used to offer the solar power plant's energy to the airport or the other customers. The PPA specifies the selling details such as the price per unit of electricity, the length of the agreement, and any other conditions. The last but not the least is the property lease agreement. This contract form is used to lease the property that is needed for the solar power facility. The airport or the project developer gives or rents other remuneration to the landlord or government body that provides the property for the project. So depending on the particular needs and circumstances of the project, these are some of the typical kind of contracts that can be used in our TR, which is all about the presentation.